Hello, Dr. Bill here. We have more SOHCAHTOA work for the ACT and SAT and other standardized tests. Once again, SOHCAHTOA is a basic trigonometric function. So let's just again review our quick SOHCAHTOA lesson. Again, I like to write it spread out to make it very clear, right? And SOHCAHTOA is always done in reference to a particular angle. So we're just going to do this and then we'll try drawing what we need for this problem. So means that the sine is going to be equal to the opposite side, sine SO, opposite over the hypotenuse, which again is just the side opposite the 90-degree angle. The cosine will be equal to the adjacent side, which is again is next to over the hypotenuse. And TOA, tangent, is going to equal the opposite side over the adjacent side. So let's see what this problem says. It says in triangle XYZ, which is not pictured, XY is perpendicular. That means perpendicular, so they meet at 90-degree angles. XY is perpendicular to XZ, and the cosine of angle XYZ is 12/13. What is the value of the tangent of angle XYZ, right? Okay, well, first let's draw this because this is confusing if we don't have a picture to assign to it. So we know that side XY is perpendicular to side XZ, right? So let's kind of do this. Okay, and then this forms a 90-degree angle, right? And then we have here that they're saying the cosine of XYZ is 12/13. Okay, so here, again, XY is perpendicular to XZ. So that means this is the X, right? Let's call this one Y, and let's call this one Z. So XY is perpendicular to XZ, and they're saying cosine of XYZ is 12/13, right? Okay. So we draw that, and again, this looks like it, may not be drawn perfectly to scale, but that doesn't matter. Let's see here. Okay, so we have that cosine of this angle, XYZ, is 12/13, right? So let's just put here the Greek letter theta, which is used oftentimes to show the angle in question, right? And then here, this is going to be equal to 12/13. So cosine, we see here, equals the adjacent side over the hypotenuse, right? And the adjacent side would be the side next to. So this is 12. The adjacent side is 12. The hypotenuse is 13. Okay, so now they want to know what the value of the tangent of angle XYZ equals, right? Well, the tangent, as we see here, is equal to the opposite side over the adjacent side, right? And the adjacent side here we know is 12, okay? So there must be a 12 in the denominator in our answer. And if we look here, the denominator is 13, so that can't be. 12 could be, 13 can't be, and 5 can't be. So the answer must be B, right? That the tangent of this angle, right, XYZ, would be equal to 5/12. Now let's give a hypothetical situation. Let's say you're taking the SAT or ACT and you have more answers here with a 12 in the denominator. So we would need to know what this side is, right? We would use the Pythagorean theorem to figure that out, right? Which is a squared plus b squared equals c squared, in a right triangle where the c is the hypotenuse, and then obviously the a squared and b squared would be the base and the height. Again, it doesn't matter whether you call the base a and the height b or vice versa, but the hypotenuse must always be c, right? So here, let's say we've got 12 squared plus the unknown squared, which we'll call b, equals the hypotenuse squared, which is 13. Okay? 12 squared is 144 plus b squared equals 13 squared, which is 169. Okay, now we want to isolate b squared. So we do that by subtracting 144 from both sides. B squared equals 169 minus 144, which is simply 25. And if b squared equals 25, the square root of b squared equals the square root of 25. The exponent and the square root sign cancel, so b is the square root of 25, which is simply 5, right? So this side is 5. Now you could have avoided using the Pythagorean theorem here again if you knew those common Pythagorean triples, which we went through in another lesson. And these are just certain very common combinations, right, for the right triangle that we can memorize. One would be 3, 4, 5, again, very common. 2 times that would be 6, 8, 10. 3 times 3, 4, 5 is 9, 12, 15. And then the other two common ones are what we see here, the 5, 12, 13. And then 7, 24, 25. These things come up again and again on the ACT and SAT, so it's good to memorize this. Because again, as soon as I started doing this and I saw 12 thirteenths, I instantly knew that the other side was 5, and since we were looking for the tangent of x, y, z, I knew immediately that that would be 5 twelfths. And you can do that as well. You can literally get this answer in seconds if you know this, okay? All right, that's great. Please subscribe to my channel if you found this lesson valuable. Like the video if you would, share it with anyone who could benefit from it, and please be sure to hit the bell icon so you can be notified of all future videos. This is Dr. Bill. Have a great one, and thank you for watching.